So this is the start of our next unit. Our second unit, rational numbers, is very similar to our first unit, number sense. We do fractions again, and we do decimals and things with percentages, so a lot of review from the first unit. But the first thing we start off with is number families. This is the interesting thing. Not only have mathematicians but came up with these names for each family. First, there's the natural numbers that go 1, 2, 3, and keep going. And there's a special symbol for the natural numbers, and you write it as a big N with an extra line. That's a mathematical symbol for natural numbers. It's not in. And whole numbers, you make a W with an extra line. Integers, what do you think it's going to be? There is some places you'll see it as an I with an extra line, but internationally and in university, more often you see it as a Z with an extra line. I don't like my extra line there. Here, I'll try that again. The I or, oh, that's a pretty one. And the reason it sometimes uses the letter Z is because it comes from the German word. Anybody speak German?
Yes, I do.
The German word Zahlen, which means number. It's a German word for number. So your integers, your positives and negative whole numbers, has that as the symbol. Are you ready for the next page or not yet? Didn't get to finish? Okay, I'll bring it back. I'll let you finish. Rational numbers, that is anything that can be written as a fraction or as a decimal that ends or repeats. And the fancy symbol is a Q with an extra line.
What's everything with an extra line?
I don't know where the extra lines come from. They just look cool.
It looks like somebody with a single dreadlock smoking.
And the Q comes from the word quotient. Quotient is dividing, and dividing is like a fraction. So that's where the symbol comes from. A decimal that terminates, what I mean by that is a decimal that ends, that doesn't keep on going forever. Something that repeats, we could write as a line over top of the 3 or a dot over top of the 3. Have you seen that before? To say that that 3 keeps on going forever, that is still a rational number. There are some numbers that go on forever but don't repeat. Do you know a number that does that?
Google. No.
Pi. Pi is not a rational number because it's 3.1415 and so on and so on and so on.
I think it ends. I think it ends with a 5.
It does not end. The last families, irrationals and then reals. Irrationals, the symbol for irrationals is a Q like rational numbers, but then we put a bar over top of it, and that means not rational. Or sometimes you see it with a squiggle in front.
The Q was wearing a hat.
Sometimes you see the not with a little dash afterwards.
It's waving his hand.
But I like the one with the line over top. These are decimals that don't repeat themselves. Patterns that go on forever but don't repeat. For example, pi which is 3.14, is a very important number.
How did they figure out that pi can end?
How they figure out that pi doesn't end is complicated. It was an open-ended question for a long time. Some people believed pi was a fraction. And so, in fact, you see ancient articles saying that pi was equal to 3. While later on people said, no, pi is a little bit more than 3. Then other people said it's a fraction. I think pi should be 22 over 7. If you type 22 over 7 into your calculator, you get close to 3.1415.
Pi is infinite. You can put it into a lot of different pieces.
22 over 7 is 3.142857 repeated.
Okay, how far can repeat as far as you can?
I have that. Yeah, I know that.
How far do you know it's pi?
Pi, I only know what happens when you put it on your calculator, although there are competitions for memorizing pi. If you would like to, I've got a book here. Guess what this book is about?
Pi.
This book is about pi. In this book, starting at the beginning, in very tiny print, you can see 3 and this book, by the time you get to the end of it, like it tells you the different stories, but there are digits that go throughout the whole book. See, they continue on the bottom of each page. Next page has some more numbers and more numbers. And in the end, they have the 1,000,000th digit of pi, which you now know is 1. The 1,000,000th digit of pi is 1. So there are some interesting things about pi. For example, did you know that the 360th digit of pi is 6? And the one right before it is 3, and the one right after it is 0. 360 at 360, and there's 360 degrees in a circle, and pi comes from a circle. Oh my goodness. It's crazy.
I'm a moose.
Pi comes from a circle?
Yes.
Do hugs, not drugs.
No, but pi, the number pi comes from a circle. Because the number pi, if you draw any circle, wow, that's one of the prettiest circles I've drawn in a while. If you draw any circle, any circle has a center, and the line that goes through the center from one side to the other has a special name. Do you remember what that name is? It's not the radius.
The circumference.
A pokeball.
Circumference is all the way around. What is the line? Radius is half. It starts with a D. It rhymes with diameter. Good. Diameter. And if you take a diameter length and you say, I would like to put one diameter length around the edge of the circle, it's not all the way around. It would go up to there. If you took another diameter length and joined it where the last one ended, it would go up to there. And that would be 2 of them around. And if you went another diameter length, it would go up to here. And 3 diameters isn't enough to go all the way around the circle. How many diameters do you need? You need 3 and a bit. And they found out that no matter what size of circle it is, the number is pi. 3.1415. Okay? That's where the number pi comes from. It's the relationship between how many diameters fit around any circle. And it doesn't matter how big or how small the circle is, you always need the same amount of diameters. And it is an irrational number. Okay.
Second number is pi is 1.
You ready? You ready to watch something else about pi? So if you spell the word pi, how do you spell pi? P-I-E, right? And you eat a pie.
And it's 3 point. Oh!
You take that number, and then flip it around.
Oh my god.
Well, it's 31.4.
Oh, I have the decimal in the wrong place, but there you go. So you take the word pi and flip it around. This only works in English. If you try it in French, it doesn't work.
There's something special about English.
So,
Because English is pretty good.
okay. So those are our irrational numbers. Include pi, many square roots, the square root of 2. is an irrational number. The square root of 3 is an irrational number. Yes. The square root of 4 is not an irrational number. Why isn't the square root of 4 an irrational number? Why isn't the square root of 4 an irrational number? That's right. So square root of 4 is equal to 2. Because 2 times 2 is 4. That's why it's not an irrational number. Square root of 4 is a natural number. And all families together, and sometimes you want to talk about every number that exists, is real numbers, and the symbol for real numbers is an R with 2 lines. So now what we're going to do is we are going to go back, and I handed out to you, again, everybody's got this written down? We're going to go back to this paper that we cut out last time. Natural numbers, whole numbers. Don't write these down yet. Integers. Do you want to use the I or the Z? For the Z? Integers. Rational numbers. Then irrational numbers. And finally, real numbers. And what we're going to do, I'll show you in a second. Oh, maybe I want to do something else. I'll make them all smaller. So pick one color, and what I'd like you to do is find all the natural numbers and color them the same. Find all the natural numbers and color them the same. So if you go back to your notes, what are the natural numbers? Natural numbers are 1, 2, 3, 4, 5, all your counting numbers. So would 2 be a natural number?
Yeah.
Yes. So I'm going to put a symbol here that it's a natural number. I'm going to choose as a color, I'm going to choose green for natural numbers, and I'm going to color this box in green. Yes. So there are the 6 that are natural numbers. After you have colored the 6 that are natural numbers with a little letter N, put it in the bottom corner for each of them. That way you've labeled that each of these are natural numbers. Now, all of your natural numbers, if we look at our description, all of our natural numbers are also whole numbers. What's different between natural numbers and whole numbers is now we include 0. So pick a different color. And anyway, and on your page, make some sort of key. Here's my naturals, and my naturals I'm going to color in green, so I'm going to color it here in green as sort of like a legend to explain what you colored afterwards. So pick another color for whole numbers. I'm going to pick red, And the only whole number that's different is 0. So we're just going to color in 0. With a different color, because that'll be the only one that's added that wasn't included before. But now for whole numbers, you're going to put a W with the 0. But since all of the natural numbers are also whole numbers, you're going to add a W to each of these.
Wait, so it's both?
Those ones are going to be both.
Well, I have a question. For
And
integers,
this one, oops,
for integers, like no, sorry. These ones right here. Wouldn't these be an integer? This has a negative.
we're going to find out. That's the next one we're doing. So I'm going to,
Zeros.
here are my wholes,
Good color.
whole numbers, and I color code those ones with red.
Bring it on.
After whole numbers, are integers. When we go back to our notes, what are integers? Integers are positive and negative whole numbers. So what are the only new numbers that are getting added? The only new numbers that are added are negative whole numbers. So pick a new color. I'm going to go with blue. Pick a new color and color all of the negative whole numbers. Once you have colored those 6 as integers,
What's the next one?
we're going to label them. Label them as integers, and because our integers also include 0 and also include 1, 2, 3, 4, we go back and we label these ones as well.
What? Are you kidding me? Do you have a black marker I can borrow?
A black marker, maybe. If we go to our notes, if we go to rationals in our notes, where every number that can be a fraction and every number that terminates or repeats.
Decimals work.
So let's go to a new color. I'm going to use this, any fraction.
What if it's negative?
Negatives are okay. So all of your fractions, and this is a decimal that ends, so that's included. Here's another decimal that ends, another decimal that ends. This one is a decimal that repeats, so it is a rational number.
How does that work though?
Here's another decimal that repeats. That's a rational number. Another decimal that repeats. It doesn't matter if it's positive or negative.
This is so. How does that work though? Because it's fraction.
Here's another fraction.
Math?
I'll explain it.
How's decimal in it?
And the reason the decimals are in there, let's look at this last one, which is 1.2654897. How many decimal places does that go till? Tenths, hundredths, thousands, 10,000s, hundreds, thousands, millions, 10 millionths.
Oh my god.
So you can write this as a fraction because it would be 1.2654897 over 10 million, and that would be the fraction. So any decimal that ends can be written that way. Now,
You would know, right?
you've labeled all of those ones as rational numbers. Did you know that you could write the number 2 as a fraction? The number 2 is the same as 2 over?
2 over 0.
No, 2 over 1. So all of our natural numbers we can also label with a Q. All of our natural numbers can be with a Q. All of our negative numbers you could put as a fraction. Negative 2 over 1, negative 11 over 1, negative 9 over 1, negative 10 over 100 over 1, and negative 89 over 1. And then down here, we'll have to add Q to this one, and a Q to that one.
Hey, can you like wait for like a couple minutes on this?
Yeah.
Okay, thank you.
Could you scroll off?
So
Just do the bottom one.
what's going to happen, and the thing that I want you to notice, is if something's a natural number, it will also be a whole number, integer and rational number.
So Q can be everything.
You can't be everything.
You have Q on every single one of them.
I have Q, all of the ones so far are rational numbers.
Nothing is impossible.
You need to like
Ages 9
slow
to
down.
10.
Yeah.
Okay, I'll give it a pause.
Welcome to a new episode of Suicide Jumper.
The last group is irrationals.
Bless you, sir.
We're going to use purple.
Stop. I don't even know who did that.
What?
Rational numbers, irrational numbers. If we go to our notes, an irrational number are decimals that do not end, some square roots, and special numbers like pi. So when we go to our color coding here,
It's like all the rest of the numbers.
we're going to include pi. These decimals continue forever, but do not repeat. So we're going to include them because they're decimals that continue forever, but don't repeat. This square root we're going to include. The square root of negative square root of 5 we're going to include, but we will not include the square root of negative 9. This number doesn't actually belong to any family because this is not a number. If you type it into your calculator, if you try to type square root of negative 9 into your calculator will tell you an error. Or it might even say not a real answer because it's not a real number.
Wait, but why is negative 3 a square root?
Well, because the negative is, or the negative root 5, the negative's outside, which is important. It's negative square root of 5. And what a square root is looking for is a number times by itself is equal to that. You can never have a number times by itself equal a negative number because a negative times a negative is always a positive.
Wouldn't negative square root of 5 be negative 2.5?
No, you're squaring it, not square rooting.
What are you doing?
Irrationals are the first ones that don't overlap. You can't be it's not a natural and an irrational. So irrational ones will always be by themselves. And finally, the last thing you need to do once you've colored it is add real number to all of them except for the one that isn't a number.
Are you serious?
They're all of these ones are real numbers except for that square root of negative 9. So I'm going to, every one of them except for the one.
What are you guys talking about?
Sometimes you guys.
Talking about Mr. Roberts.
There we go. Added the R to them all.
I'm pretty sure that's still right. No.
And the only one that doesn't belong to anything is the square root of negative 9. We don't have to do any math with square roots of negatives. There is math that exists with square roots of negative. If you want to add the symbol for this last one,
Oh, it's the lonely sea.
it's the lonely C because it is a complex number, also known as an imaginary number,
But why does that negative 9
because they don't really exist.
Can I keep this or give it back?
Also known as
You have to give it back.
like unicorns.
Complex.